Alright, so today we'll be factoring special cases. Now technically you don't have to do this one, but this is actually factoring special cases can work really fast in your favor if you can recognize it. So for example, if I'm taking a look at a difference of perfect squares, okay, if I notice the first term's a perfect square and the second term's a perfect square and there's a minus sign between them, I can quickly just move to here without thinking of factoring, the easy way, like it says on the factoring flowchart. Same thing here. If I know this is first is a perfect square and this second one is a perfect square, and I know that I can go times these two together and then times them by 2 and I get this middle term number, then I know I can actually do the perfect square trinomial, which is just write it once, okay, and then have the square on it, and then whatever sign is here will go here inside of the actual parentheses. Okay? Right? So I know that, but you can actually just do them any regular old way. You could actually just factor these the easy way, and I'll show you both in a sec. Hold on, let's look onto the factoring flowchart. Okay, so once again, you always look for your greatest common factor. Okay, if you factored out, good. If not, then you count how many terms. Okay, so last time we talked about 3, and we talked about not a perfect square trinomial. We'll talk about that today. We'll go on this path in a sec. But we talked about what if it's not, and then we said, okay, you're going to factor the easy way, which is this way, or you're going to factor the long way, which is using the AC method. Okay, so today we're going to talk about these two methods. And if you notice, there's two different paths. So if you have two terms, you're going to have a difference of perfect squares. Okay, and how do we separate that? It's going to be a squared minus b squared equals a plus b times a minus b. Okay, now if it has 3 terms, it's going to be more than likely a perfect square trinomial, but you have to double check it to make sure that you're dealing with a squared plus b squared. Okay, well, a squared plus or minus 2ab plus or minus b, or not plus or minus, plus b squared, and it's going to be a plus or minus b squared. Now this way is going to be awfully confusing in the beginning because this is such a new notation, but we're going to go over these two methods. Now, just to go over the factoring flowchart, we will not cover these in Algebra 1. Sum or difference of cubes or sum of squares, and actually, if it is a sum of squares, it's not factorable. So just so you know, if you see a minus sign between two squares, you can factor it. But if you don't see a minus sign, you can't factor it. Okay? Alright, and we just talked about these two ways, and we talked about greatest common factoring before, and next time we will talk about factor by grouping. Okay, but these two ways are going to be some of the easier ways to work with real fast. Okay, now some of them you might actually have to factor out a greatest common factor first. So like for example, let's say we had 18x squared minus 32. Now some of you guys are going, wait, those aren't perfect squares at all. You are correct. So let's factor out a number so that they are perfect squares. Okay. Well, let's just factor a number, see where we go from there. So what number goes into both 18 and 32? 2. 2 is the biggest number that goes into both of those, surprisingly. So this will turn into 2 parentheses 9x squared, which is a perfect square, minus 16, which is a perfect square. Now if you notice, I have a perfect square and a perfect square. Okay, look at this. Perfect square minus, perfect square minus. So all I need to do is, it's almost like I'm square rooting both the a and b and just putting them in their respective slots. So you can go off to the side and go, oh, what's the square root of 9x squared? Well, that's going to be 3x. And you would be correct. And what's the square root of 16? That would be 4, and you would be correct. So I could just rewrite this in factored form as 2, remember the 2 from the beginning with the greatest common factor, 3x plus 4, 3x minus 4. Okay, now some of you guys might be asking, wait, can we put the minus 4 first and then plus 4 second? Yes, you can do whatever order you want, but as long as you follow the rules of commutativity. Okay, now a real popular one that not a lot of people like is this one right here, x to the 8th minus y to the 8th. Okay, now surprisingly enough, those don't look like perfect squares. Okay, but you have to remember in exponents, okay, if I square root x to the 8th, okay, I'm going to get x to the 4th. All right, and if I square root y to the 8th, I'm going to get y to the 4th, which is a really nice thing. So what this will actually become is this will become x to the 4th minus y to the 4th, x to the 4th plus y to the 4th. Okay? Now if you notice, one of those has a plus sign between them, so I'm not even going to think about difference of perfect squares. But I'm going to ask myself, are these perfect squares because there's a subtraction between them? Okay, and what I'm going to do is I'm going to check it out. So I square root x to the 4th, and that is going to be x squared. Ooh, that looks good. And I'm going to square root y to the 4th, and I'm going to get the same thing, y squared. And yes, when you square root a number with an exponent, it will actually just you just divide it by 2. So now we're going to have x squared minus y squared, x squared plus y squared, and then we're going to have that plain old x to the 4th plus y to the 4th at the end. Okay, and resist the urge to factor this because that is a sum of perfect squares and we don't want to mess with that. Well, guess what? Do we have another difference of perfect squares? And this is actually kind of cool, so you can keep factoring this. Okay, all right, because guess what? Square root of x squared is x, and this will be the final step in this one, just to break the tension in the ice. So this will be y squared. Square root of y squared is going to be y. Okay, so the very beginning will turn into x minus y, x plus y, x squared plus y squared, x to the 4th plus y to the 4th. And let me go back and change that 0 because that should be a parentheses. There we go. Okay, so you're going to end up with x minus y times x plus y times x squared plus y squared times x to the 4th times y to the 4th. And that is just that one simple little two-term binomial separated into all of its glorious factors. So if I were to multiply all these, I would get x to the 8th minus y to the 8th. And that's a really cool thing about it. Okay. Alright, so here's some pretty simple ones right here. Perfect square, perfect square. This is going to be perfect square trinomial. Now, if I take the square root of this, which is x, and this is 4, and go times those together, and I get 4x, and then times it by 2, guess what? I get 8x. So I can go ahead and transform this one without thinking too much about it. X plus 4 squared, and I'm done. I don't even have to factor that at all because I know all I need to do is just do the square root of the first, square root of the last, and then use the sign in the middle. Oops, I'm going to circle it rather than underline it because it looks like a plus or minus. Okay, now this one I need to factor out first. So I'm going to factor out a 2, so it becomes x squared minus 10x plus 25. Okay. All right, and then I'm going to notice, okay, I could square root this, I could square root this, okay, and then that would be x and 5, and 5 times x would be 5x, times by 2 would be 10, so I've got it. Okay, now the only thing I need to do is I need to make sure I bring down a 2, never forget about that, and in this case, I'm not going to put a plus in the middle, I'm going to put a minus, because the minus is the sign right there. Okay, so x minus 5. And if you think about it, I need 2 negative 5s to get to negative 10. So I got 2 times x minus 5 squared. Okay, now on the next page we'll talk about some common errors people make and some common tricks and tips to help you out. Alright, so taking a look at this one, this would be a difference of perfect squares, but some people go, wait, 1 isn't a perfect square? Yes, it is. So if I square root this and I square root this, this will turn into 4x minus 1 and 4x plus 1. And voila, I'm done. I've factored it. I can move on. This one, most people will try to factor, but you can't. And this is actually one of the most famous problems in the world, because this actually came about because of this problem actually caused a lot of problems because it started the whole revolution on imaginary numbers, and you'll learn more about that in algebra too. Because if you think about it, this is literally what number times itself is going to add to 1. Well, you could do a whole bunch, but if I set this problem equal to 0, and this is where the problem came in, and I'm kind of jumping ahead of myself. Okay, what number times itself get you, that's obviously a positive number, plus 1 is going to get you 0. That there's no possibility. So that set off a whole thing. So that's actually a famous problem. But the problem that most people make is they think, oh, perfect square, and then they do their factoring. But you cannot factor. Hugely important that you understand that. Okay, now this one is another common error people make. Oh, perfect square, boom, boom. And then they just go ahead and write x minus 4, and then they do the square. Okay, and the reason why that does not work is because even though this is 4 and this is x, 4 times x is 4x, and 4x times 2 is not negative 3, so that definitely does not work. And amazingly enough, this one, let me see. Yep, cannot factor. Okay, so you just leave it alone. It's in its most factorable form. You at least tried your best. When you're factoring, sometimes you can factor, sometimes you can't. No big worry. Now this one, a lot of people go, oh my gosh, there's so much, I can't factor. Yes, you can actually. This is a difference of perfect squares. Okay, so this is going to be factored into the form of 2xy minus 5x cubed. Okay, and then you're going to have the other one is 2xy plus 5x cubed. And voila, you have factored your form. Now just remember, when you're doing the square root of an or a variable with an exponent, you can just basically just divide that by 2. Okay, you can divide that by 2 and you're good. See, like for example, in these ones we divide these by 2, we divide these by 2, and that's how we get the 1s right there. Okay, but you can actually take something really complicated and actually simplify it really fast. Okay, that's it for factoring special cases. I'll talk to you later. Bye.